Mm-hmm.
All right, here we go. So welcome everyone. Thank you very much for coming. This is Xiangpeng Hao's last major this is he's going to present his intern work, the work he's done this summer for uh us as his intern. He's been a phenomenal experience. He's going to continue working with us in the fall in a different capacity, which we'll talk about later. But I think right now he's going to explain what he spent his summer doing. That
Great, great. Yeah. Thanks for the introduction. So today I'm going to present my intern project on the faster data fusion with StringView, and this work is done together with Andrew Lam. A lot of help for him. Yeah. Okay. So before we jump into the details, I want to give everybody a very high level end result that how far we made. Uh, So basically, this is ClickBench queries with 43 queries, and we make 23 queries faster, and no queries are slower, and the 20 queries has no performance change. So that is pretty significant considering that DataFusion is already performed pretty well in ClickBench queries. So that is how we make how we make DataFusion faster with StringView, and then we're going to discuss how we make it possible and what are the aspects of change. So what are the things what are the focus I'm sorry, yeah. So how we leverage StringView's unique properties to make DataFusion faster. So, so here I want to discuss on what is StringView. I want to give a very high level idea of this new data representation. So basically, let's consider the logical counter on the first column where we have 4 strings: Apache DataFusion, InfluxDB, Arrow Rust implementation, and Arrow Apache DataFusion again. And the string array is the current standard of arrow string representation, which is pretty it works well for the initial purpose of arrows faster data exchange and vectorized execution, right? So basically, string array is pretty simple. It have 2 components: offset buffer, offset array, and the underlying buffer. So offset array, so basically you have the for the first string, you just point it to the beginning of the buffer, and second string you point to the length, the 17. So this is 17 bytes, so you point to 17 here, and this 8 bytes, so you will point to 25 here. So it's pretty compact and it's pretty simple and straightforward. And the string view array is a little bit complicated in a way that it tries to improve the existing string array in several aspects. So string view array notably have the 2 components. First is the view array, and each of the view here is 16 bytes, and it also have multiple buffers. Different to the one like string array only have 1 buffer, but a string view array allows multiple buffers. And for strings that are shorter than 12 bytes, we have the first 4 bytes have as the length, and the rest of the 12 bytes to inline the strings entirely. For example, for InfluxDB, we only have 8 bytes, so we can completely inline those 8 bytes into the view struct. So that will reduce some memory copy. Okay. So we can reduce some of the memory interactions. We get just one memory access, and then we can get the entire strings. And for strings that are longer than 12 bytes, we have a buffer ID, which allows us to find the physical location of the buffer. For example, buffer 0, we're going to look up, have a buffer lookup to find the buffer 0 is at this buffer. And we use the offset to look up the string bytes inside the buffer. And lastly, we have a prefix, like 4 byte prefix, that is to inline the prefix of the string, so that hopefully those inline 4 byte prefix can help us do faster string comparisons. So that is string the difference between string array and string view array. And so here are some notable difference. String array have one simple and continuous buffer, which again is suitable for the arrow's initial purpose of efficient data exchange. So, but string view array is a new, as arrow being used in more like a query semantics, we want more efficient string support for queries. So we have this inline prefix so that when comparing data, comparing strings, we can look first to check the inline bytes. For example, this is very effective for to decide whether the strings are equal or like equal, non-equal. Like inline prefix pretty effective. And we also have fully inline short strings, if string lengths are like shorter than 12 bytes, which is like 60% of the case in real world data sets. Those string bytes can be fully inlined fully inlined in the view structs and making very efficient like one less memory interaction. And we have a flexible buffer layout. We will talk about this later, how we use what does this mean and how we use it to make Parquet loading faster. So basically, here we have the buffer ID here allows us to have multiple buffers instead of just one single continuous buffer in string array. And lastly, you may have noticed that the first string and the last string are the same. So in the string array, we have to repeat the string bytes here, because there's no way for us to express that those strings are the same. But here, in string view array, we can just use the same offset 0 to point to the same underlying bytes so that we can reuse strings, and that is very efficient if the string view array has a lot of repeating values. So that is string view array. And the string view itself, it is pretty simple, and it reduces some of the string copies, and it have accelerated comparisons. And it's like the idea is not new. Like a lot of short string optimizations have done this before, and it's a very classic idea in database and in larger data processing community. And it's actually simple because like implementing string view is like only 5% of the total work. But the actual most important, like most challenging part of the work is to integrating StringView in DataFusion in the query engines to make StringView efficient in query semantics. So what we found is that a naive implementation with StringView into DataFusion will make the queries, like almost every query are slower, and some of them are like 20 times slower. Yeah, so it needs a very careful implementation, very careful profiling and optimization. So DataFusion integration takes most of the work. And actually, myself has done like 50 pull requests and 10K lines of code with, like together with many external contributions, and we finally make that that very nice performance improvements. So yeah, basically I'm trying to explain why this simple idea needs to take 3 months to work to finish. Yeah. Okay, so StringView is faster in 3 aspects. The first aspect is it has offset, and the offset and buffer format allows less copying, which we will discuss first. And then we'll discuss how we use the inline string prefix to accelerate comparisons. And also the last part is the flexible layout allows reusing bytes for repeating string values. And yes, as we discussed before, the most of the work is to integrating StringView into DataFusion, which like we will apply those 3 aspects into actual DataFusion semantics and how we make it faster for each of the use cases. The first case is we need to do faster Parquet loading. So because less copying allows to reuse the Parquet the Parquet decoded page, which we'll discuss later. And the second, fast comparison will allow us to do faster filtering take operations, which is very common for string operations. And the last part, reusing string bytes, will allow us to do faster string aggregations, which we'll discuss the last. So, and the first part is flexible buffer format allows less copying, and how we make it faster in Parquet loading. So here's a Parquet decoded Parquet page, which has the has a string length. So this is 17 length, 4 bytes length, followed by the actual data, and this is 8 byte length, followed by the the actual string data. And then this is a required format for the string array, where there's so where each string is followed by each other, and there's no there's no length in between the strings. So this layout mismatch here, decode packet page and string array. So that's why you have to copy and consolidate the strings into a new buffer, which is pretty bad for the query semantics, because most of the strings are filtered out after loading. Right. So, but for the string view array, we can have that very flexible, like a very flexible representation that we can just use set this buffer decoder page as buffer 0, and then we can use the offset here, like for here points to Apache DataFusion, and this is in line, so we don't have to point anywhere, and the 37 points to the Arrow Rust implementation. So which is pretty cool, because we can directly use the data from the Parquet, and we because that will allow us to reduce some copies. And yeah, that's reuse buffer, and the string will save some extra copy, which will lead to faster performance. And especially for like a large scale data where like a lot of string are involved. Right. So, and this is pretty simple, and it's a very simple idea, and it works when we figure out when we know the every details. But before we get to the real performance gains, we have to go through a lot of performance nuances like UTF-8 validation, implicit copies, unintuitive compiler optimizations, and I can spend the entire day talking about those optimizations, but for this presentation, we probably don't have time to cover them. So if you are really interested, we can check out our blog post, 2 series blog post, which is supposed to publish today, I think. Yeah. So basically, in a very high level way, UTF-8 validation says validating this buffer is 10 times faster than validating this buffers. So making an extra copy is actually faster. Yeah, so so actually making string arrays are actually faster. So we have a very clever way to work around that problem, and yeah, so make it so that UTF-8 validation is not a problem. And implicit copy basic says so everything we do here is to avoid the string copy, but a lot of times we have to there are many implicit copies we are not aware of, so we have to diagnose and chase every copy every memory locations to make sure that those are necessary. Intuitive compiler implementation is basic thing. Sometimes the compiler is not able to generate efficient code, so we have to look at the assembly and write code in a particular way that we can guide the compiler to generate efficient code for us. Yeah, so those are pretty fun topic, and you can find detailed explanations in our blog post. So, and here's the end-to-end performance. We have a ClickBench query where we select how many we want to know how many URLs contains Google. So there's a pretty simple query, and most of the time is spent on loading data from Parquet. And the y-axis shows the query time, and the x-axis, this is without StringView, it takes 1.1 millisecond, 1.1 seconds, and with StringView, it takes only 800-ish milliseconds, and which is a 24% improvement. That is pretty cool because for queries, for simple queries like this, we can improve like 24%, and that is that's pretty significant. So now we move to the second part where we have like inline, how we leverage the inline string prefix to allow faster comparisons. So basically, how we make filtering and take faster. So let's consider we want to compare two strings. The first is Apache DataFusion. The second is InfluxDB. For string array, we have to first go to the offset array, and so that's one memory load. And then we go to the underlying buffer, which is the second memory load. And for the InfluxDB here, we have to go to the offset array, and then go to the underlying buffer. So that is in total of 4 memory access, which is not very efficient. But for the StringView array, because we most time we only want to compare, like for here the observation is that we don't even have to look at the entire strings. We only have to look the first string character, which is letter A and the letter I. We can decide they are different, right? And we can even decide the order. So for string view array, we can directly go to the first review struct, which reads the inline bytes. And then for the second bytes, it is fully inline, so that's our second memory access. So for string view array, comparing those two strings and deciding their orders or equality only takes 2 memory access, while for the string array, you have to do like 4 memory access. Right, so string array inline string prefix will reduce memory access, which will naturally lead to higher performance. So, and the faster take. So take operation is basically saying we want to take a subset of the array. This is often happening after we do the comparison. For example, here we want to compare. We want to take the first and third element. So basically Apache DataFusion and the Arrow Rust implementation and into a new array. And because string array requires like a continuous single compact buffer, which requires to copy and consolidate the string bytes into like a new buffer, which is not very efficient, especially when we want to take a lot of strings. But for the string view array, we can just construct the view struct, which is fix the size, and then we can directly point to the like original buffer. So we can directly reusing the original buffer and pretending that the buffer is from us, right? So here we can just use the offset 0 to point to here, and the offset 25 to point to the arrow Rust implementation. So because we can reuse the buffer, we don't copy the like the very long string over and over again, so we can have better performance. So yeah, string view has minimal data movement. That's why it has better performance. So again, even with this simple idea, it has a lot of performance nuances, and is theoretically it is faster, but to get those faster end-to-end performance, we have to consider a lot of things. For example, the when to GC, the GC timing. So basically, GC is so since we are reusing the buffer, we are holding the buffer for pretty long time, and which is not great because that will lead to excessive memory usage. So GC is basically saying we want to garbage collect the data so that when for example, if we have 1 million strings and we only have one string element, but instead of holding the entire 1 million string buffer, we just maybe it's better just to copy the data to a new place and release the large buffer. And out of function inlining, so most of the time function inlining makes us comparisons fast, make a faster code, but sometimes the compiler like excessive function inlining can actually generate a slower code because, for example, bloated code size, or sometimes the compiler is not able to find some of the optimizations. And so we have to dig into the assembly code and look at what's going on. And actually, what we found in our case is a register building, which is basically the CPU used all of the registers, and some of the registers go to the memory, which is caused very terrible performance. And the buffer size tuning, so basically string array has one continuous buffer, so there's no need to tune the size, but string view array allows multiple datas. And so it's easy to create a string view array with millions of buffers, which is terrible for performance because like in that case, even some simple operations, for example, get memory size, you have to check the memory size of 1 million buffers. Which is terrible. And we have to do something there to like integrate some of the DataFusion semantics to make sure the buffer size is appropriate for each of the individual use case. Okay, and again, those topics are very fancy. They're cool, and I can keep talking about them. And if you're really interested, you can check out our blog post, and they will be published today. So here is string operation performance. The y-axis is the filter time, and the x-axis string with string view, and this is without string view is with string view, and it's 2.2 seconds, and this is 4.9 seconds, and a total improvement of 32%, and that translates to 70% of end-to-end performance, which is also pretty nice. So our last part will be how we leveraging the string how we like reusing the string bytes to make a string aggregation faster. So basically, we have already seen this before. So the first string and the last string are the same. For the string array, you have to repeat the string bytes in the buffer, which is suboptimal. But for the string view array, you can just point use all the same offset because the offsets are independent of each other. So you can just point the offset to the same location so that you can reuse the strings, and which is pretty cool if in the query have a lot of repeating strings. So this actually act like a dictionary array where if you have low distinct count of duplicate strings, then you can reuse in the string bytes and save a lot of memory. And so we have identified some of the query semantics where there are a lot of repeating strings. For example, in this ClickBench queries, we want to group by user ID and search phase. Here, let's say search phase only have two distinct values, and theoretically they only have two values, but because they have multi-column group by, they have user ID have a prefix, so together they make unique combinations, and that makes like a lot of repeating strings in the string array. For that case, string view array with string view array can significantly reduce the memory usage and thus better performance. And we have haven't finished yet. We have like a ongoing like draft up here there, and we have to fix some of the edge cases there. But the high level idea is like the high level implementation idea is already there, and so lastly, we want to revisit this figure again. So we have 43 ClickBench queries, and among the 43 queries, 60% of the queries, 60% of the queries have strings, and 40% of queries have no strings, so they have no performance change. And among the 60% of the queries, 88% of the string queries have improved performance, and the rest of the query has no performance change. So like this is a very neat win. So there's no regression, and there's like a clear win for DataFusion and its users. So the conclusion, StringView has improved the performance of string intensive queries by to 20% to 2x, and it will benefit ILX once it is bit stabilized, which is, I think, is going to be later this month or like it will be soon, like because we have cleared most of the blockers to stabilize it, and it will be enabled by default in DataFusion, and I think it also helps ILX. And the naive implementation makes string queries slower, and that's why we do a lot of work to optimize it to fit the StringView semantics to the DataFusion semantics. Like we ended up with 50 merged pull requests, 10K lines of code in Rust and DataFusion. And lastly, I want to thank InfluxDB for sponsoring this work as my summer intern project. And this has been a really, really great experience for me. And I really enjoy working with InfluxDB. Yeah. Thank you. And I'm happy to take any questions.
Awesome. Thank you so much, Xiangpeng. Yeah, we have a couple minutes. Does anyone have any questions? Well, you all understood that perfectly, I'm sure. How about I'll start going? Could you go back? Oh, sorry. Who's gonna say?
I was just saying that was awesome. Thank you.
Thanks. Yeah, thanks.
Maybe, Xiangpeng, could you go back to the slide that shows the performance improvements per each query and kind of like explain why one query got 2.5 times, 2 times faster, and then some only got small amounts? Like, what's different about those queries?
I think like for the query 10 and query 11, they have a very heavy string filtering there. So like basically a lot of so like for the rest of query, like for example, those queries, you have mixed integer columns and string columns. But for those queries, you have a lot of almost only string queries, and the so the filtering selectivity is pretty high, and it will drop a lot of queries, drop a lot of data, so avoid a lot of copies there. And I think that's the reason it is a lot faster.
Yeah, I think this is a fabulous example of like it's a very simple idea, right? We're just gonna not copy the string around a little bit, right? Like it's super simple, but 50 pull requests, 100,000 lines of code later, it's actually still quite impressive that you do this without causing regressions. But yeah, I mean, it was an epic amount of work. So
yeah, that's yeah, we have gone through like the first time I get the string view into DataFusion, like I was kind of surprised. Every query is slower. Some of the query even cost a lot of memory. I was thinking, okay, maybe it's a terrible idea. Yeah, and
yeah,
we gradually like make the regression. We fix each of the regression, and we gradually make the advantage larger and make like regressions equal with the baseline. Yeah, it take a lot of efforts.
one of my favorite stories is Xiangpeng we were talking about that. He's like, I don't understand. Making smaller strings is actually slower than making large strings, right? Like I got this thing and like you copy like strings that are 20 bytes. That's actually faster somehow than copying strings that are like 5 bytes. Like,
Yeah,
what the hell's going, which should be the opposite, right? Because like those short bytes should all be inlined and you shouldn't have to do this extra memory cover. Like, why the hell is it slower? Right? Which
yeah.
is, yeah. There's a good answer for that, by the way, in the blog, but we'll leave that as a teaser. But I mean, it comes down to LLVM as being super, super smart when it knows long strings, basically. It can be smarter than the short strings. So anyway.
Yeah.
Right.
Hey.
Ooh. All right. Well, thank you all very much. I'll post this recording and slides and stuff online. Great job, Xiangpeng.
Yeah, thanks.
Yeah.
Thanks everyone for joining.